Astronomers using the Chandra X-ray Observatory made a surprising discovery. Scientists found G29-38, a white dwarf in Pisces, devouring its planets. Gravity from the dead star is tearing apart the once massive planets and turning them into hot, glowing plasma. But sometimes the host star eats too much, and planets fight back. According to University of California astronomers, if a super-Jupiter planet collided with a star, it would create a huge shock wave that could cause the star to expel its entire atmosphere of extremely hot plasma into space. The intense process can tear the star apart internally. Planets smash into stars and release matter and gas into space due to the force of the impact. After ejection, matter and gas can form a new world. But these outcast planets often face harsh conditions as they travel through space alone. To adapt to deep, cold space, how do wandering planets bend physics? Which other strange worlds does the universe hold? Science doesn't know how rogue planets got out of their orbits and wander around space. Billion of them are estimated in the Milky Way alone. Planets from young star systems, where protoplanets compete for building material, are more likely to become rogue, say astronomers. In these systems, planets collide or orbit too close, pushing a smaller planet into space. Even older planets can become lost. Passing stars or black holes can upset a planetary system's delicate balance, ejecting planets. Exiled planets face terrible fates. Once outside its star system, its surface cools to space temperature, -270 degrees C -455 degrees Fahrenheit. Oceans of liquid water freeze. Such a planet would have no seasons or day/night cycles. But Florida Tech professor Manasvi Lingam thinks life may still be thriving on rogue planets. How is that possible? Imagine an Earth-like rocky planet that wanders. The core can radiate heat for billions of years. Ice on its surface could melt and form water with this heat. Scientists have found liquid water lakes and rivers beneath Antarctica's ice with microbes, mollusks, and strange fish. Similar life forms may exist under wandering planets' ice. A planet with a dense hydrogen atmosphere could support life. Rogue worlds that retain their atmospheres prevent core heat from escaping into space. Heat and gravity from a large moon orbiting such planets would stretch and compress its neighbor. NASA will soon test the hypothesis of such planets using extrasolar object interceptors. Compact radioisotope electric propulsion probes intercept extrasolar objects. If a rogue planet or other celestial body enters our solar system, interceptors will return with samples. These spacecraft can catch up with an extrasolar object and return samples to Earth in 10 years. Outcast planets aren't the only planets scientists like. Poltergeist, PSRB 1257 plus 12, is 2,300 light-years away in Virgo. Astronomers have long puzzled over this planet. Planets orbiting a pulsar, which forms when a massive star collapses in a violent explosion, have little chance of survival, making its existence so puzzling. Poltergeist survived and was unharmed despite all odds. Astronomers found space debris on the planet. Poltergeist formed from shattered celestial bodies thrown into space after a supernova explosion. The planet should be rocky, say scientists. Poltergeist is constantly bombarded by microwave radiation from its star's magnetic field, one of the strongest. All living things die in such conditions, but not on Earth. Recent studies suggest that Poltergeist's dense atmosphere could protect it from X-rays and gamma rays, making it habitable. The planet's radiation levels are still much higher than Earth's, limiting its habitability to simple organisms. Deinococcus radiodurans, a resilient bacterium on Earth, can survive radiation 500 times higher than humans. So similar organisms may survive on Poltergeist. Another unusual exoplanet is Beta Pictoris b, 63 light-years from Earth. The dense gas and dust around its young star had hidden it from scientists for years. The Beta Pictoris star is about 20 million years old. Astronomers found 30 exocomets in the star's system in 2022, similar in size to solar system comets. The true face of Beta Pictoris b has been revealed to scientists after years of dense dust. With the Very Large Telescope, scientists tracked the planet's orbit around its star for 4 years. Recently, these stunning images were released. Beta Pictoris b, a supergiant planet, has 1.65 times Jupiter's radius and 11 times its mass. It rotates quickly, 1 revolution on its axis in 8.1 hours, faster than the solar system's gas giant's 10 hours. The planet's main mystery remains unsolved. Beta Pictoris b is 10 astronomical units from its star, about as far as Saturn is from the Sun. Astronomers estimate the gas giant's temperature at 1,451 degrees Celsius, 2,644 degrees Fahrenheit, which is impossible at that distance from its star. The planet's massive mass and dense dust cover may be retaining heat, but this is unconfirmed. One more massive gas giant dominates Jupiter's category. The 2022 discovery of AB Aurigae b in the Auriga constellation is 9 times more massive than our solar system's gas giant, and has a radius of 1.12 times Jupiter. Scientists call AB Aurigae b Elephant Planet. The system of its young star, 38 times brighter than the Sun, is still forming it. Additionally, the planet grows, defying physical laws. It lives on the edge of its star system, twice as far from the Sun as Pluto and almost 100 times farther than Earth. A year on the exoplanet is 587.7 Earth years. Standard scientific models say AB Aurigae b couldn't have gained such a large mass this far from the star. Usually, gravity pulls matter and gas towards the protoplanet's core. However, the planet on the star system's periphery appears to lack building materials. This implies AB Aurigae b formed differently. Planets may form from space debris. When a young star's disk cools under gravity, it may break into planet-sized pieces. One of these pieces may have formed the giant planet. It absorbs the abundant gas in the young star system to grow. The mass of AB Aurigae b is approaching that of a brown dwarf. Let's examine another system with a size disparity. Planet GJ3512b is 30 light-years from Earth. This Ursa Major gas giant is half the size of Jupiter. It orbits a red dwarf almost 5 times smaller and 50 times fainter than the Sun. Sun is 1,050 times more massive than Jupiter, but red dwarf GJ3512 is only 270 times the planet's mass. The discovery of GJ3512b, a gas giant orbiting a small star, challenges planetary formation theories. We thought only Earth-sized planets, or more massive super-Earths, could exist in such systems, and that gas giants could not form around small stars due to a lack of gas and dust in their disks. This assumption may have been due to the difficulty of detecting such planets in their parent star's dim light. Gas giants like GJ3512b are thought to form from debris in stellar disks, but the shortage of material in a small star's disk makes their presence even more surprising. Scientists hope to solve these world's mysteries with the James Webb Space Telescope and European Space Mission, Ariel. Exoplanet research will be its focus in 2029. We hope you enjoyed this tour of our universe's most intriguing planets.